So welcome. Today is EC201 and we are doing Chapter 5. We're going to be talking about elasticity today. Now, please make a note, the slides I'm using are from the 11th edition of the textbook. In the 12th and 13th editions of the textbook, there are some formula errors that you need to pay attention to. Also, as I lecture today, be careful. I'm going to draw special attention to an equation that you're going to need in order to do the homework and to do the exam. So please make note of that. There are going to be lots of equations coming at you. Please do not get overwhelmed. Just make sure you're paying close attention as to what we're doing here. So elasticity is a tool that we use in order to tell us how big a change is. Think about a demand curve for a minute. We know that price and quantity demanded move in different directions. Sometimes in economics, you get certain items that oppose each other. One thing's making something better, something's making it worse, or bigger or smaller, etc. Pardon the normative language there. In this case, knowing how big each of the arrows are is a critical detail in knowing what's actually going to happen. So to do this, we use the concept of elasticity. Now, elasticity has been stolen as a concept from economics by political scientists, sociologists. This is one of those intellectual constructs that is so useful, it's been hijacked by a bunch of other disciplines. So whenever we talk about elasticity, we would generally speak of elasticity of A with respect to B. Now remember, this is percentage. The triangle here is delta, that's change. So that's the percentage change of A divided by the percentage change of B. So you can use any two things in here. However, it's generally known that generally speaking, B causes A. So there's kind of hidden in elasticity an inference that B is causing A. Doesn't always have to be the case, but usually that's what it is. So the first elasticity I'm going to show you is the own price elasticity of the demand. I know it says price elasticity. I use the word own price because we have other ones besides this. So this is the percentage change in quantity demanded divided by the percentage change in price. So remember, this is a demand elasticity. So if price is going up, quantity demanded is going down, which means this is always going to be a negative number. And herein is the point. Elasticities are always negative. Elasticities are always numbers. An own price demand elasticity will always be a negative number. Some elasticities are positive numbers. But an elasticity always comes out to a concrete number. But first I want to show you why slope doesn't work. Because slope is the old metric that we had, the slope of the demand curve, for responsiveness. So here are two graphs. Pardon me yawn, guys, I am sorry. Here we have two graphs. They're both price per pound of steak. Price per pound, price per pound. Here's pounds of steak. Only this one in B here, this is measured in ounces of steak. So there's 16 ounces in the pound, so 10 times 16 is 160, 5 times 16 is 80. So these two graphs are exactly the same. They convey exactly the same information. However, look, the slopes come out to be two totally different numbers. This is a problem. When you graduate, if you have a job and you're going out to your job, and your boss says, hey, if I invest another $10,000 in advertising, increase the advertising budget by $10,000, what's that going to do to my sales? If your answer is, well, sir, it depends on how you measure it. Oh, I'm sorry, ma'am, it depends on how you measure it. That's called the wrong answer. Metrics of responsiveness. You do not want to be unit dependent. You have to be able to get rid of the units. And that is the main feature of elasticity. Elasticity works regardless of how you measure pounds, ounces, whatever you're measuring. So there are several different types. The first are two extremes. The first is perfectly inelastic demand. Perfectly inelastic demand, quantity demanded does not respond at all to a change in price. So the number for inelastic demand, remember these solve to a number, is 0. Quantity demanded does not respond. So a perfectly inelastic demand curve would be a vertical line, is what that would look like. Now, inelastic demand, let me give you an example. Imagine you are in the middle of the desert. There's nothing there. You're dying of thirst, and one person pulls up and happens to have some life-saving water. It doesn't really matter what they're charging. You have to pay it. Otherwise, you're dead, right? Another example, a real-life example of inelastic demand curves. Patented life-saving medicines that there are no real substitutes for. Guess what? That's inelastic demand. You either pay the money for the medicine or you're dead. That's the perfect inelastic demand. The other extreme is perfectly elastic demand. With perfectly elastic demand, if you raise your price by 1 penny, bam, you lose all your sales instantly. Perfectly elastic demand is when the demand curve is just a horizontal line. The number for perfectly elastic demand is negative infinity. So what would be elastic? Imagine you are going to bake some bread and you go to the grocery store and you need some flour. You need white, enriched, normal flour. You're sitting at the grocery store and you see the flour, 1 pound of flour is what you need. You got that on the shelf there. One costs 40 cents, one costs 45 cents, one costs 50 cents. It's the same flour in the bags, just different label on top. Which one are you going to buy? Well, if it's the same stuff, why am I buying the more expensive? Most people would get the 40 cents, and only if the 40 cents is out would they get the 45. And that's the point of perfectly elastic demand. The 45 and the 50-cent flour will not sell as long as there's 40 cents there, and there will be. It's perfectly elastic demand. So by raising their price by a nickel, they lost all their sales. The best real-life examples of perfectly elastic demand curves are agriculture. If you think about it, if I'm growing corn, my corn is probably just as good as the neighbor across the street's corn, is just as good. A lot of agricultural products have perfectly elastic demand curves. Here's a mnemonic device to help you remember it. The E in elastic tends to be a horizontal line. The I in inelastic demand curve is vertical. There you go. Now, between the extremes, there are 3 types. Now, please note here, demand curves are demand elasticities are negative. By tradition, they talk about the absolute value of the demand elasticity. I actually don't to help, and I actually will use the negative sign for you in order to help you on the test. If you are calculating a demand elasticity on the exam, and it's known price demand elasticity, and you see an answer that is a positive number, that is by definition an incorrect answer. The number for a demand elasticity will always solve to be a negative number. So elastic demand is where the percentage change in quantity demanded is larger than the percentage change in price. So that means if we go back here to the definition, elastic demand is where the numerator is bigger than the denominator. That means the value is going to be between -1 and -infinity, not including -1 and not including -infinity. But now we know percentage change in quantity demanded is bigger than percentage change in price. We're going to weaponize this, and I'll show you how to use this knowledge in a minute. Another type is inelastic demand. Inelastic demand is where percentage change in quantity demanded is less than the percentage change in price. So that is a number between 0 and -1, not including 0 and not including -1. Now that leaves us the magical case of -1. -1 is called unit elastic, and that is where the two are equal. Percentage change in quantity demanded is the exact same as the percentage change in price. Magical things happen at the unit elastic point, and I'll show you that in a minute. Here we go, unit elastic. They're exactly the same. Own price demand elasticity will be -1 or an absolute value of positive. Do not write this down on your note cards. Do not study this for the exam, this equation. In general, this is how you calculate percentage change in quantity demand. You take the change in quantity demand, Q2 minus Q1, and you divide it by Q1. Now, this equation works when the distance between Q2 and Q1 is very small. Dr. Yoder, how small is small? A penny works. But what if it's more than a penny? Then you got problems. Here's the same thing in price. Do not use this equation. Again, here's a penny. Sometimes even 1 unit of output here could be too big. So this is the formal definition of it. When you use P1 as the base, if you think about this in terms of price, imagine dollars, right? $10 minus $8 is $2. So P2 minus P1 is $1. But we're dividing dollars by dollars. Whenever you divide dollars by dollars, you get a number without units. And that's where we lose our units, and it makes the answer unit independent, which is the feature that we wanted for the elasticity. However, this percentage change in price and the percentage change in quantity before it are highly sensitive to this P1 value. So, formal definition, percentage change in quantity, percentage change in price. This is the equation you want to use for your exam and for your homework. This is called the midpoint formula. When the distance between P1 and P2 or Q1 and Q2 is non-negligible, okay, if it's a reasonable distance. In the old equation, it was Q1 here. Now what we're doing is we're just going to add these together and go halfway. So if this was 10, Q2 was 10 and Q1 was 8. 10 plus 8 is 18, divided by 2 is 9. So notice we're going right between 10 and 8. We're going halfway between it, and that's 9. That's because this equation is highly sensitive to this Q1 value. So what we're doing is we're splitting the difference. Do the same thing with price. So here is the entire midpoint formula. So if you notice, the 100% will cancel out. This is the elasticity of good X with respect to the price of X. So this nomenclature here, this writing, means it's an elasticity of a good with respect to its own price. That tells you what kind of elasticity it is. There's a bunch of them. Q2 minus Q1, add them together, halfway between. P2 minus P1, add them together, halfway between. Now, for those of you who are sufficiently nerdy and have TI calculators, I do not care if you write, I did this, a little program in your calculator where you put in Q1, Q2, P1, P2, and it spits out the elasticity automatically and runs this computation. Don't care. That's up to you. As far as I'm concerned, if you're smart enough to build a piece of capital in order to run it, you're smart enough to know how to use it. So we're good. But this is the equation you're expected to know for both your homework and for your exam. Now, point elasticity is a version of that. Instead of having a distance, Q1, Q2, what about the elasticity at a given point? So change in quantity over Q1, change in price over P1, but the change is so infinitesimally small, it may as well be zero, which is meaningless. But this is where we can borrow some help from calculus for those of you who have it. So change in quantity over change in price, remember, is just the reciprocal of the slope of the demand curve. So if you have the demand curve, particularly if it's a nonlinear demand curve, and you can pass a derivative through that, just take the reciprocal of it, or raise the entire thing to -1, and then you multiply that by the price over quantity you're interested in. And this will give you an elasticity at that particular point with an infinitesimally small change. For the case of a linear demand curve, if the slope was 3, the reciprocal of it would be 1/3. And then you just take the price over quantity. This is not required on your exam, but this is very, very useful when you get back into the real world. So let's practice this. Here we go. We're going to do own price elasticity of demand between points alpha and bravo. So here we go. So P1 right here is going to be 10. Q1 is going to be 2. P2 is going to be 9. And Q2 is going to be 4. So that's going to give us Q2 minus Q1. So Q2 is 4 minus Q1 is 2. 4 minus 2. Then you add them together and divide by 2. 2 plus 4 is 6. 6 divided by 2 is 3. So in the numerator, we have 2. In the denominator, we have 3. 2/3 is 0.66 times 100%. So percentage change in quantity demanded is 66.7%. Then we move on to price. P2 is 9. P1 is 10. 9 minus 10 is -1. There's our negative sign that we need. Remember, if you do the math and you don't get a negative sign, something's wrong. 10 plus 9 is 19. 19 divided by 2 is 9.5. This comes to -10.5%. And for the elasticity, 66.7% divided by 10.5%, that comes to -6.33. So let's think. Is that inelastic, unit elastic, or elastic? Notice the numerator is greater than the denominator, so that would make this an elastic demand curve. Now, if you come back here and do the same equation for C and D and do the math again, you'll notice it's inelastic, negative 0.294. So notice something interesting. The slope along that line, it was a straight line. That's going to be a constant number. But the elasticity is actually changing at all points along the line. That means the effectiveness of different changes are going to be different at all points along the line. Now, this graph gives you a really good shorthand. Really good. Now, you know you're facing a multiple guess exam. So let's say you're calculating an own price demand elasticity. Well, you know any positive number is automatically a wrong answer. You can get rid of that. But as long as the demand curve is straight, notice what happens here. If it's up in this region of the curve, it's going to be an elastic number. If it's down in this region, it's going to be an inelastic number. So if you have an answer, if you're being asked to calculate like we just did up in here, and you look at the answers and you rule out all the positive ones, and you look and there's only one that's elastic and the other is inelastic, you already know what the answer is just by remembering this graph, that the elastics are up in that range without even having to do the calculation. So let's start using this idea. Total revenue for a business is equal to price times quantity, right? Price of what you're selling times the quantity. So if I'm a business and I change price, what's going to happen to my revenue? Well, the answer is it depends. We know that if we raise price, quantity demanded will fall. But so we have an up arrow and a down arrow, right? The problem is we don't know which is bigger. If price is going up, if the up arrow is bigger than the down arrow, then that means total revenue will increase. If the down arrow here is bigger than the up arrow, that means if you raise price, total revenue will fall. So in order to know what happens for a change in price on your total revenue for your business, you have to know which of these two arrows is bigger. That's where elasticity comes in. Percentage change in quantity demanded is right here. Percentage change in price is right here. So if it's elastic, I know quantity demanded is the bigger arrow. If it's inelastic, I know price is the bigger arrow. So here we go. Change in total revenue is equal to 0 if a unit elastic, that's -1, that means these changes are the same. If you're inelastic, that means the price arrow is bigger than the quantity arrow. So if you increase your price, the price arrow is bigger than the quantity arrow, that means your total revenue will go up. If it's elastic, that means quantity arrow is bigger than your price arrow. So if you're raising prices and the down arrow is bigger, that means the total revenue is going down. Inverse is true for a decrease. So what determines your elasticity? Well, first is very simple. The availability of substitutes. Now this is where that construct I mentioned back in Chapter 3 becomes very critical. Remember when we talked about substitutes and I said, remember this is a continuum between perfect substitutes and close substitutes. And if you have perfect substitutes, you're most likely going to have a perfectly elastic demand curve. Why? Because the second you raise the price above what your competitor's pricing, everybody just piles into the competitor because it's the same stuff. If you have no substitutes, you're most likely an inelastic demand curve. You either buy it from them or you're gone, right? you're not buying it. Second is the importance of being unimportant. So let me put it this way. For those of you who have a mortgage or pay your own rent, think about it. Could you take a 10% increase in your rent year after year and get away with it without having to move? I know I couldn't. I'm pretty elastic when it comes to rent because it's such a big thing. But yet I can take a 10% increase year after year of my Starbucks coffee. There you go. Starbucks did that to me recently. Starbucks did a 10% increase in my coffee. So if you do the math, if I was getting coffee Monday through Friday, 10% increase in price, what would that mean? Well, if I still got coffee Monday through Friday, I would be, in this case, perfectly inelastic. But 10% reduction in that would be I quit going to Starbucks one day a week because of it. One day every 2 weeks. That would be 10%, Monday through Friday. But actually my response to the 10% is I quit going on Fridays. So that was a 20% reduction in quantity demanded for a 10% increase in price. So Starbucks actually lost revenue by raising their price for me. Now be careful, guys. We just talked about changes in revenue. That's not profit. Revenue is not profit. What else? Luxuries versus necessities. That's great. Time dimension. All right. So imagine, congratulations, you've graduated college and you're making $150,000 a year because you were in my class, not some other schmoes, so you actually have skills. So you're now making $150,000 a year. And it's your lunch break. You knock off, you go down, you normally buy your lunch. And the place you buy your lunch, it's normally $5. You like it, you go there every day. You get down there, you wait the line, you get to the front, you pay your $5. You get back, you eat it, and then your lunch break's over and you're back at it. All right. So one day, you knock off for lunch, you go down to where you normally get your lunch, you have your $5 bill in your hand, you get there and they say, oh, sorry, we had to raise our prices, it's $10 now. What are you gonna do? Well, it's your lunch break. I mean, you could go without lunch, but you've already waited the line. There's not enough time to go somewhere else to wait another line. And you're kind of stuck. You got to pay it. So in the short run, you're kind of stuck. You got to pay for it. Okay. But what are you going to do tomorrow? You going to go back there? Oh, hell no. Not for me. I'm going to a different place, or I'm brown bagging it and bringing my own lunch. So in the short run, a lot of people get stuck. But in the long run, as things become more and more and more available, as people get better ideas, substitutes come online, households adjust their behavior, and away you go. So here you go. Same idea for delicatessen sandwiches. In the short run, the demand curve is inelastic. As time goes on, it becomes much more elastic. We've got other elasticities. This is the income elasticity of demand. So it's the percentage change in quantity demanded over the percentage change in income. Now this thing could be a negative or positive number for an income elasticity. If it's a positive number, that's a normal good. If it's a negative number, it's an inferior good. So be careful there. Positive number is a normal good. Negative number is an inferior good. We have a cross-price demand elasticity. So this is the percentage change in the quantity of good Y whenever we change the price of X. So these are substitutes and complements. So if this is a positive number, it's a substitute. If it's a negative number, remember the betas, positive, negative. If it's a negative number, that's a complement. We also have supply elasticities. Percentage change in quantity supplied over the percentage change in price. We use this in national emergencies, like during the COVID. The question was, okay, so if the price of N95 masks went up, how many more can be supplied and how long? And we're starting to use this. HR managers, here you go. Well, I need a certain number of people to apply. I think I'm going to need probably 100 qualified applicants to find who we need for the job. Okay. So what are you paying? I'm paying this. Well, we're not getting that. All right. So what's the elasticity of labor supply that tells you what the wage rate has to be for you to get the certain number of applicants you need to pick from? So it's change in labor supply based on the wage rate. All right. Now I'm going to use this, and I'm going to make a normative argument. And I'm not doing this to tell you what you should think, but I'm going to use this idea of elasticity as a critical thinking exercise. And I just play along with me, but please do not feel I'm moralizing at you. In public policy, in government public policy, there's this idea of something called a thin tax. The idea is very simple. You want to have a free society, but there are things that are undesirable, usually drinking, smoking, recreational drugs, these kind of things. And so what you do is you put a tax on these quote unquote sins to increase the price, and the idea is to cut down on that behavior at the margins. General thinking is you tax what you want less of and you subsidize what you want more of. State of Colorado, when they first legalized recreational marijuana, put a 10% sin tax on the marijuana. They made so much money, it was surreal. It made so much money, the neighboring states were suing the state of Colorado in federal court to try to get some of it. I mean, they just made it hand over fist. But remember, the fundamental idea of a sin tax is to try to get people to choose, hey, that's too expensive, I don't think I'm going to do that. So they raise a real question. Ask yourself, do you know any smokers? I've met a few, and I don't smoke, but I know a few. This question says, who are the elastic smokers? So if we as a society raise the price of cigarettes 10%, who's the person who's going to walk into the cigarette store and go, oh, you know, you raised my cigarettes 10%, I don't think I'm going to smoke anymore? Do you guys know this person? I've never met this person. Oh, you know, I was going to buy a carton, I'll just, you know, I'll take, instead of 10 packs, I'll just take 9 because he raised it 10% and I'm, you know, elastic. And you know, I'm just going to cut down a little bit because it's too much. Who is this person? Usually people who are addicted to something are inelastic in their demand because of the addiction. And this begs a question. If you were really trying to reduce quantity demanded for smoking by adding a tax, and it's inelastic, you're going to need a 50, 60, 100% tax to actually get movement there. So why is the tax only 10%? And once you process that, some people come to a conclusion that it's really not about a sin tax at all. It's really not about actually reducing smoking. It's about raising government revenue. It's about transferring the tax burden from one segment of society to another segment of society because you feel morally justified in doing so. Well, they chose to smoke cigarettes. They don't have to pay it if they don't want to. Come on, dude. You know they're addicted to the crap. Let's get honest with it. You know you got them by the balls and you're just dragging them around town. Who are the elastic smokers? Is it really about trying to reduce smoking, or is it about transferring the tax burden from one group of society to another group of society because you feel morally superior to them and you just don't like them, who are predominantly smokers, blue collar, et cetera, et cetera? So let's be honest. Is this really about a sin tax when you look at the elasticity, or is this really about transferring the tax burden? Now, I'm not trying to moralize at you, but I want you to see how this idea of elasticity can be applied to questions of public policy to give you a smell test of what they're arguing about and let you think, is that really the case? So for example, an excise tax. An excise tax is a per unit tax on goods. We have it on gasoline, we have it on cigarettes. So a mayor of a city proposes a tax of $1 per avocado, and they sell 1,000 avocados currently per day. So will that be $365 a year in taxes? Okay, so we currently sell 1,000 avocados a day, 365 days a year. We'll do $1 per avocado. That'll be $365 a year, and so that's what they put in the budget. So what's going to happen? Well, here we go. Here's the current demand curve. Here's the supply curve. Current price of an avocado is $2, and there's 1,000 sold a day. Now, when you add $1 tax, we're just going to shift up the supply curve by $1. So notice the old equilibrium price was $2. But when you shift it up by $1, the new equilibrium price is $2.50. Equilibrium quantity is 500. So you're getting your dollar tax, but you're only getting 500 avocados a day. But also notice this. Okay. This is where you get a deadweight loss. This is an underproduction deadweight loss. This bit of the tax is paid for by the consumers. This top bit. This bottom bit of the deadweight loss, that deadweight loss is lost profits. That deadweight loss is borne by the producers. So the tax incidence in this case, we can figure out who's actually going to end up. Yeah, I know, oh, well, it's an excise tax, there is a sales tax. Doesn't matter who's the tax man standing next to. Years ago, about 4 or 5 years ago, there was this proposal here in Oregon to tax the utility companies. And they said, oh, we're just going to tax utility companies. It's not going to be passed on. It's not going to be blah, 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 blah. And I'm sitting there going, what kind of weed are you smoking? I need to get the name of that because that is some pretty good stuff that you've got there. Utilities, think about it. Can you live without your cell phone? Seriously. Could you go through life without your cell phone? Cell phones are considered telecommunications is considered a lifeline utility to the point that they give out free cell phones to people who need them for emergency use to call 911 and to get medical help. I mean, it's considered a utility, a major essential utility. So if we start taxing all the cell phone providers an extra 1%, they're going to pass it on. Of course they are. Why would they not pass it on? The extra 1% into their bill. They can. Who's going to tell them, well, no, I really don't want to pay that. You know, I don't have to. Seriously. Why? Because the demand curve for that is relatively inelastic. means they can pass it mostly on to the consumer. If the demand curve is elastic and you do that, then what are you going to do? You're the producer. So there you go. That's the end of elasticity. Thank you very much for coming and for listening to this. I appreciate you. Please do your homework. If you have questions, give me a call, send me an email, and I'll do my best to get back with you. Thanks.